Hello and welcome to part 7 of the VR character series. In this part we will be implementing a simple climbing system. Originally I planned to add a sliding mechanic, however it is a bit too performance heavy for blueprints because it relies on the tick event. The sliding mechanic will be added in the C++ version. Before we start, I wanted to thank everyone who watches my videos and subscribed. Together we've managed to reach 200 subscribers. It really means a lot to me and it makes me really excited for the future of this channel. So thank you for your continued support and let's get right into it. As usual, we will start by adding some variables. So let's open up our VR character blueprint. In the variables section, let's create a new variable called isClimbingRight, and it's of type bool, and I will add it to the category climbing. There we go. Then we also want to duplicate this variable and create it for the climbing left. Then next we want to know our previous climbing location. So we will add a variable called previous climbing location. And this is of type vector. And while climbing, we will shrink down the collision capsule of our character so we can easily climb up on ledges, meaning we have to add an offset to the mesh. So let's also create a variable for that called climbing body z offset, and it's of type float. All of these variables are going into the category climbing. And we also want to be able to control which objects we can actually grab. So we will create another variable called climbable objects. Go. And this is of type object type query. Then also make sure to make this into an array, compile, and now you can add a default value. I will add it to world static. You can add whatever you like. You could also, for example, if you want to climb physics bodies, you can if you want to. However, this climbing system is only for static meshes. The one that I will create in the C++ variant is actually going to include skeletal meshes that are moving and also sliding down and also rotating with an object in any direction. Now that that's done, we will add one more variable to our movement section. I will call this base step height. And this is of type float. Make sure to change it back from an array to a single. And then let's add this to the movement category. We need this because when we start climbing, when we don't set the step height of our movement component to 0, it will snap the character back to the floor while we're in that range, which is the default, I believe, is 45 centimeters. So while you're in there, you won't be moving upward, and then suddenly you will snap upward. And then when you get into the max stepping height of the ground, you will just snap to the ground, which in my experience wasn't really a pleasant experience. So we need to remember our base step height, which I'm going to set the default value here of 45. So we can set that once we're back on the ground. And with that, we can go to our functions and let's create a new function called start climbing. This I will also add to the category climbing. Then in here, we want to add an input called isClimbing. And we also want to make sure to pass this by reference. And we want a second bool, which is called isOtherClimbing, other referring to the other hand. This is also passed by reference. And at last, we want to get a motion controller. I will call it MC. This is of type motion controller component. And this does not need to be passed by reference. So we can untick that. Then first, we want to get the world location of our motion controller, because here we will trace for our climbable objects. So let's do a sphere trace by objects, for objects. Let's connect this. The radius can be our grab radius. And the object type is our climbable objects. Oh, I just realized I did a multi-sphere trace. We don't want a multi-sphere trace. We only want a single sphere trace for objects. There we go. Then we can connect this to start and end. There we go. Now we can break the hit result and get our hit actor and check if it is valid. Then if it is, we will get our is climbing input and we will set by ref var and set this to true. Then we will get our is other climbing and we will set this to false also by ref var. We need this for the update climbing function, so it knows when to switch to the other hand, because climbing with both hands at the same time isn't, in VR, there isn't really a good use case for that. So I usually do it that you just switch to the latest hand that's grabbed. Then we want to get our motion controller, so get MC. And we once again want to get the world location and set our previous climb location. After that, we want to get our character movement component and make sure to set the velocity to 0. Because if you're, for example, running, jumping, and then grabbing onto a ledge while your velocity isn't 0, it can be a bit buggy. So I just simply set it to 0. Then we also want to set the max step height to 0. This is what I meant before. That's why we created our base step height in the movement category. And at last, we also want to set the gravity scale to 0. Because otherwise our collision capsule would constantly fall down, which again would make things very buggy. Then the next function we are going to create is called update climbing. Let's also add this to the climbing category. Here we are also going to add 2 inputs. First is the motion controller, and the second is called is climbing. The is climbing one is a bool. We do not need to pass any of those by reference, so this is fine. Actually, I'm going to move this up. There we go. And now we can check if this is true with a branch. And if it is, we want to get our previous climbing location and the world location from our motion controller. World location. And then subtract it from our previous climbing location. Then we are going to add this to our actor. So add actor world offset. This is why we also pass the other is climbing variable to our start function, because if the other one is still true and we were to subtract this from this, then there's a good chance that this still has the value of, let's say, our left hand, even though here we're passing our right hand, and then it would just launch us in a direction, and we don't want that. And after we've added the actor world offset, we want to get the motion controller, so get MC. Then we also want to get the world location of it and set this to the previous climbing location. This is already it for the update climbing function. Next, we are going to add the stop climbing function. Also add it to the category climbing. Now in here, we will need 3 inputs. The first is the is climbing. Second one is the is other climbing. And also make sure that the is climbing one is passed by reference. And the last one is again our motion controller called MC. First, we want to check if we are climbing. So the branch. If it is, we want to get our is climbing. You can also drag this out and do it like that, but I don't want to use that too much, so I'm going to do it like this. And then I'm going to set this by ref var and set it to false, if this is true. Then we want to check if our is other climbing is true. So if, and now only if this is false, we want to set the velocity of our character movement. So set velocity. We will need some space for this one. And to calculate our velocity, we will get our previous climbing location. Previous climbing location. Get our motion controller. Oh, I just realized this should not be passed by reference. This can be passed normally. Then we want to get the world location, subtract it from our previous climbing location. And then we also want to make sure to divide it by the delta seconds. So make sure to change this pin into a float double precision and get the world delta seconds. And connect this to the new velocity. With this, if our other hand isn't grabbing, we can launch ourselves off and won't just stop in the air. And then after this, we of course also want to set our max step height to our base step height. So get base step height. And also set the gravity scale to 1 again. There we go. The next function is for applying the climbing z offset. So again, create a new function and we will call it apply climbing body z offset. Now in here we will first get our height. So get height of the character. Then from this we want to subtract. And here we want to subtract the diameter of our capsule component. So let's get our capsule component. And from here, get the scaled capsule radius. Then multiply this by 2. So we get the diameter. And then subtract this. Then since our climbing body Z offset is supposed to move our character mesh down, we also need to invert this. So multiply it by -1. Here we go. And then I will save this in a new local variable called target height. So promote to local variable, target height. Next, we want to get our climbing body Z offset and check if it is greater than our target height. If it is, then we want to again get our climbing body Z offset and lerp it, lerp load, and we want to lerp it to the target height. Actually, I just realized I named this a bit wrong. Let's not call this target height, but target offset. There we go. So let's lerp it to the target offset. And for the alpha, we can just get the world delta seconds again. If you wanted to lerp faster, you can simply multiply this value. Or, of course, input your own value like 0.2, for example. But I've got the best results by just using the world delta seconds. But feel free to play around with it. Then, if this is true, we want to set the climbing body Z offset. And we will set it to our lerp value. Then next, we will get the capsule component. And here we want to set the capsule half height. make some space. Then here we also want to lerp it, so it slowly reduces itself from the current half height, from the player's height, for example, down to the radius. So we will get the scaled capsule half height and the scaled capsule radius. And here again, we can just copy this lerp node together with the world delta seconds and lerp it from the capsule half height down to the capsule radius. And then input this into the half height. There we go. That's it for the apply climbing body Z offset function. Then the next function is going to be the reset climbing body Z offset function. Also part of the climbing category. And here we will add an input called target half height. And this is of type float. And here we want to do the opposite. So we want to scale up our half height from the capsule up to our regular height and the climbing body Z offset down to 0. So we will get the climbing body Z offset, there we go, and lerp it down to 0. And the alpha again is the get world delta seconds. Then we will set this to the climbing body Z offset. And after that, get the capsule component. Get the scaled capsule half height. And then you again can copy this lerp node. And here we will get our input, get target half height. There we go. And then we simply set the half height of the capsule to the lerp value. All we need to do now is change some functions from before. So let's go into the character category in the functions and change the get height ratio function. Here we no longer can use the capsule half height because when we shrink it down, our character would just lay down while we're still in the air climbing. Now I haven't actually figured out a good way to fit the animations to climb with our character, meaning our legs will just be hanging there, and after we've climbed up a ledge, it will look like our character just comes out of the ground. I first thought about creating a system where we do line traces, but adding even more collision traces to something that is in the tick event in blueprints will not be very feasible. The same reason why I also haven't implemented the sliding mechanic for this part, because it will simply just overwhelm the blueprint system, in my opinion. You can, of course, still try to do something like that, but I believe it's better to be done in C++, where you have more than enough performance to actually do all of these collision traces. So let's get rid of this for now and move this out of the way a bit. And first, let's get our camera and then get the world location. Actually, I will move this return node back a bit as well. There we go. Now we can split this, and since we only need the Z value, and then here we want to add the scaled radius. So scaled capsule radius. There we go. After that, we will add a subtract node. But before we can use it, we will need to get the world location of our capsule. Also split it and subtract the half height from the Z value. This will give us the floor where the collision capsule is standing on. And then from this, we will add our climbing body Z offset. We will add it and not subtract it because remember, this value will be negative and therefore we need to add it for it to be subtracted. And then we can subtract this from our camera location. And here, just to clarify, we add the capsule radius to our camera because the camera isn't actually the highest point of our character. the actual highest point is like the top of our head. For example, your eyes are usually not the highest point of your head, meaning we need to add the radius to get the actual highest point. And then we can divide this by our height variable. There we go. And return this value. The next function we will update is the update mesh location and rotation function. And in here, all we need to do, actually, let's go back to our get height ratio and copy the add node and the climbing body z offset variable. Then back in our update mesh rotation and location function, move this back a bit and also this down here, and add our climbing body z offset to this z value. And once down here. There we go. And this is already it for this function, because now if we shrink down our collision capsule, then our climbing body z offset value will increase, or well, get smaller actually, because it goes in the negative, but you know what I mean. And then it will move down the character while we're climbing, meaning the head still aligns with our camera. Last function that we need to update is the calculate half height function. Now in here, let's get rid of this. And down here, we simply need the radius of our capsule component. This we can disconnect, and here we will get the VR origin. And now from our camera Z location, we want to subtract the VR origin location. And then to that, we will add our capsule radius. This first part will give us our height in the real world. So the distance between your floor and your VR headset. And then we will add the scaled capsule radius, because again, to get the full half height of the capsule component, we need to add this little bit that is above your eyes. Now this is the full height. Now we will simply divide this by 2 to get the half height. And then we will add a branch. And here we will check if we are climbing with one of our hands. So add an OR condition. And here we simply want to check if is climbing right or is climbing left. If it is, we want to call our apply climbing body z offset function. And if it's false, we want to reset the climbing body z offset. And here we can input our target half height. Now that we have all our functions, we can go back into the event graph. And in our grab right, we can first call the update climbing function. In the triggered event, here we will is climbing right. We'll input this, and of course the RMC, the right motion controller. Then down here in the started event, if we want to grab a weapon, but it is not valid, then here we want to get the start climbing function. And for the is climbing, we again get the is climbing right. And is other climbing is the is climbing left variable. And the MC is again the right motion controller, RMC. There we go. And then in our completed function, we want to call the stop climbing function. So move this a little bit. And here again, we can copy these 3 and input them like above. And then, of course, do the same for the left. One thing that I forgot before we are finished, we need to go into our apply XY offset. And in here where we have our body Z offset, we need to add another pin to the add node and add our climbing body Z offset. because otherwise our camera will be too high up and not where our capsule is, and then we still couldn't climb up a ledge, because even though our collision capsule is just a ball, it is still basically on our feet, and of course it would still be in the way. So this fixed that. And yeah, this is pretty much it. In the next part we are going to fix the trigger hand animations for the weapons. If this video was helpful to you, make sure to leave a like and subscribe. Let me know in the comments if you need any help, and I will see you next time. Bye!